traditional record. Okay, so brief intro. This product council meeting is focusing on the multi-scheme deployments workstream. And today we have, I was just checking actually. We have one of the workstream leads here. We have Innocent. I can't see E. E promised me that she'd be here today. Copier, Min, Ni, do you know if he is joining?
Yes, I'm Paul. E is on a trip. She's on a mission. She's in the US currently right now. I thought she has communicated to you whether she's joining or not. If she has confirmed to you that she's joining, she will. But what she told me is that she'll be away for the next few weeks and may not be available. So I wasn't sure that she was going to make it to this meeting.
No, she told me that she was going to make it to this meeting.
Okay, all right.
So, I was going to arrange it for last week, but she told me that she could only do it today. Okay, well, in the meantime then, this work stream obviously is being led by Innocent and E. But so the purpose of this meeting today is to define the objectives for this work stream in a little more detail for this PI, not necessarily overall, because it may extend beyond one PI. I also want us to define the acceptance criteria for this PI. So the definition of done effectively for this work stream. And I'm hoping that we will also be able to recruit contributors. So before we get into that, I want to emphasize the model that we have adopted for this work stream for multi-scheme deployments. The model has been defined by the Mojaloop Foundation. That work has been undertaken by Michael, and I wanted Michael to spend some time before we get into the work of the workstream leads, etc., to take us through that model, and so we can get a sense of the how it all hangs together and the work that needs to be done. So, Michael, are you able to do that first before we go
on? Yes, I am. I had kind of been thinking of going through the process of resolving an address in a multi-scheme environment. Do you think that would be helpful, or should I go back to one of the more general presentations that we talked about?
I was hoping that you could quickly go through the general approach
and
then talk about the address resolution, because that's a vital element for other work streams.
Okay. In that case, hold on a moment. Okay, so I will go back then, with your permission, to a presentation which we talked about before the convening in earlier council. So are you seeing that?
Yes, seeing that.
Yes.
Okay. So what are we trying to do? We're trying to support payments between customers of VFSPs which belong to different payment schemes. And that for us means IIPS payment schemes. It should support any number of schemes and any topography of schemes. And examples are the hub and spoke one, which is what we're currently proposing, for instance, for COMESA. A linear one, where essentially schemes, you go through one scheme to get to all the other schemes, or indeed combinations of. So essentially, we don't want this to be dependent on the choice of a particular topography of schemes. We want it to be invisible to the participants. So we don't want DFSPs to have to know that they are operating in a multi-scheme environment. They should be able to work in exactly the same way they do in an ordinary scheme environment. And that essentially means that it's the switches that will be doing the work in this model. And it should allow schemes to operate in single scheme or multi-scheme environments without modification. Again, this is something that we want to be able. We don't want people to have to implement a different kind of scheme if they're in a multi-scheme environment. And finally, we want to be able to retain all of the features of a single scheme motor loop system. Again, we don't want a cut down version for inter-scheme stuff. So here is an example architecture. You've probably seen this a number of times. On the left-hand side, we've got jurisdictional IPS, which in this case is Malawi. On the right-hand side, we've got another jurisdictional scheme, in this case Zambia, and we've got a multi-currency scheme at the top, which is the regional scheme, and the three schemes are connected together by a simple hub and spoke arrangement where each of the jurisdictional schemes connects to the regional scheme. Okay, so what problems then do we need to do this? We need to say, how do we identify beneficiaries when they're in different countries? How do we know where to route a message to if it's intended for a DFSP in another scheme? How do we ensure that obligations inside all of the schemes always balance with each other? That is, that we don't wind up with non-double entry obligations. How can we manage timeouts reliably? How are we to manage free funding requirements when a payment is passing through multiple schemes? And how can we ensure that payments can be tracked across all of the schemes through which they pass? So I'm going to start with beneficiary identification. This is somewhat out of date because I've done some more thinking on that, which I will show you later on. But essentially, the situation today is that participants maintain their association and identify using the participant's endpoint. This may not be true for all Oracle types. For instance, for phone numbers, people might use Pathfinder. If the identifier is not found in Oracle, then the payment can't be made. You just get an error back. In a multi-scheme environment, we can either retain the existing system and forward new entries and changes to the oracles of all of the other schemes, or we can move to an event-driven system. Now, I'm going to go through this very quickly because I've moved away from the event-driven system in my design work. Reason being, I had a long and, as usual, productive talk with Miller at the convening, and he convinced me that the event-driven system, well, we could certainly support it, but it's not necessarily a good thing to do. So this essentially says participants don't need to register identifiers. When an Oracle can't match an identifier, it asks all the DFSPs it knows about, whether they recognize it. If one does, it does a positive identification, and the Oracle caches the response. Next time a DFSP asks about that identifier, the Oracle simply has an identification and forwards the request straight to the DFSP. If the customers move their account, then the DFSP rejects the request and the round robin that I referred to above starts again. It's expensive compared with the existing system the first time a customer is a beneficiary, but if subsequently it's equivalent. No changes required at the DFSP. The DFSP simply responds to get parties' requests as it would at the moment. It works unmodified for oracles which connect to third-party systems like Pathfinder, but it might be more efficient than the existing systems for those since we cache the results on return. And exactly the same as the existing system, it needs some strategy for coping with duplicates, but because that's a problem that everything has at the moment, I'm going to pen that and not talk about it. We could make the system more efficient by caching the DFSP and identifier information on other calls, such as post quotes or post transaction requests. Okay, so we could implement in the ALS, which is simple to do, all the oracles would work in the same way, and individual oracles wouldn't need to be modified. Address resolution methods would be configurable, so you could say this ALS works like this. They wouldn't all have to work in the same way. So existing schemes would continue to work. Okay, so now let's go through a scenario. No, we're not going to go through a scenario. I will go through it very quickly, but I've got a better version of this.
Michael,
Yes.
if we're not going to do the on-demand style, then let's not spend time on it, essentially. Let's go to the one where we actually are doing.
Okay, message routing.
Thank you.
Okay, so how do we connect schemes together? And the answer is via a proxy. We used to call it a cross-network provider, but I think a proxy describes better what we intend it to do. It's a specialized implementation of an adapter, which has two interfaces. In most adapters, the interfaces are different and the adapter converts content between them. In our implementation, however, the interfaces can be the same. Both sides of the adapter would speak, for instance, ISO 20022, but each side speaks it to a different scheme. So the proxy acts as a concentrator. In any given scheme, the switch can talk to the proxy without needing to know how to route to any of the DFSPs in the other schemes on the other side of the proxy. So effectively, it's a simple way of saying, if you want to know about all of the things that aren't in your scheme, then talk to this proxy. There may be more than one proxy attached to a scheme, and that works too. But we need to be able to associate a DFSP ID with the proxy that represents it. So DFSP should be able to address a message to the intended recipient without needing to know if that recipient's in the same scheme as them or not. And the underlying architecture should manage routing the message via the proxies to the correct destination. So our proposal is that proxies should be registered in each scheme to which they're attached. The switch can obtain on demand a list of the proxies which are attached to it, or either switch, as we'd say. When the switch receives a message from a proxy, it stores the association between the DFSP which sent the message and the proxy which forwarded it. Now, if it needs to send a message to that DFSP, it knows which proxy to send the message to. It doesn't need to have any knowledge about the whole route the message will go to. It just needs to know the proximate destination, the proxy that it needs to send to, in order to pass that message on its way. This will provide, we think, a simple mechanism to manage routing between arbitrary numbers and topographies of schemes and DFSPs. It should work in exactly the same way for large and extremely complicated interactions as it does for small and simple ones. And it's based around the simple module loop principle. You always find out where a DFSP is before you try to communicate with them. And this via the get parties. Okay, now let's look at balancing obligations between schemes. Here the requirement is, when a payment passes through a scheme, the scheme must record its passage. This is true even if none of the eventual parties to a payment are direct members of that scheme, because we need to ensure that we can always trace the complete path of a payment through the system. The balances, as we always say, between position accounts in any scheme must always net to zero. This means that every credit in the scheme must be balanced by a corresponding debit. Our proposal here is each proxy has position and settlement ledgers attached to it in both the module loop schemes to which it belongs. For any given module loop scheme, this account might be called something like funds due to or from the DFSPs represented by this proxy, and that's all of the DFSPs. So where a proxy is a gateway through into a larger number of DFSPs, effectively all of their traffic will be concentrated into a single position account. For any given transfer through a proxy, a debit in one of the schemes it's attached to will be exactly matched by a credit in the other scheme it's attached to. For instance, if we are making a payment of 100 Kenyan shillings from DFSP-A to DFSP-B, we've got DFSP-A goes to Scheme 1 and Scheme 2 goes to DFSP-B. Proxy A sits between those two, and okay, it says ZAR and not Kenyan shillings, but I hope you'll forgive me. So the first DFSP is debited 100 Rand or Kenyan shillings, and the proxy on Scheme 1 is credited with 100 of whatever those things are. The opposite happens on the other side. The proxy on Scheme 2 is debited with 100 Kenyan shillings, and the DFSP on Scheme 2 is credited with 100 Kenyan shillings. So you can see that in both schemes, the net of all of the credits and debits is 0, and that will be true however complicated the arrangement between those things is. So that's what we plan to do with balancing payments, or sorry, balancing obligations. Now I want to talk about managing timeouts. Now, we time transfers out because we don't want people's funds to be unreachable when transactions might not complete. We don't want a situation where a transaction stays open for hours or sometimes days without completing. Meanwhile, poor people's funds are being reserved, they can't get access to them. Now, at present, in Moduloop, when a debtor DFSP requests execution of a payment, it specifies when the transfer should time out. Our principles are there should be a single source of truth for timeout management, and in a Moduloop world, that's the switch. No participant should time a transfer out unilaterally. And when a participant asks after the status of a transfer, the answer might be pending, which is equivalent to I don't know. This means not yet finalized, and a participant now must wait until they can obtain a finalized state before timing a transfer out. Now, the question is, how do we replicate these principles in an ecosystem where a transfer may pass through multiple switches? Our proposal is a relatively simple one. A switch should only enforce a timeout if it's the switch to which the creditor DFSP is directly attached. Requests for information about a transfer should be addressed to the creditor party in any case, so they will always be forwarded to that switch. Now we have a single source of truth again. Not only that, because it's the last switch before we get to the creditor, it's the one which is most likely to be able to get a timeout accurately. So that covers that. I'll just go back to that and say that we think is a simple rule which will enable us to retain our single source of truth idea for the timing out of transfers. Liquidity cover. Now, we know why we have liquidity cover for the creditor DFSP. The requirement for a proxy is that it should be backed by good funds administered by the schemes that it belongs to and available to both schemes. They might be held in a single account, or they might be held in different accounts. And holding them in a single account is not a credit risk, since we've already said by definition, a credit in one scheme is mirrored by a debit in another scheme. The good funds required by a proxy are really working capital. They're only needed so that we can allow schemes to settle independently of each other, which in a large and complex network may be a thing worth having. So what if the debtor DFSP's good funds are known to some other scheme? I don't know what that means, sorry. Yes. So in each scheme, a proxy represents the net of all the transactions between that scheme and the other schemes which the proxy represents. And therefore its good funds account represents that same net. It's administered in effect by the scheme to improve the efficiency of a multi-scheme system. So the creditor DFSP may rely on the liquidity check carried out by its scheme against its local proxy to warrant that sufficient funds are available to reimburse it for the payment it's executed. Alternatively, if schemes trust each other, then we might say liquidity cover only needs to be held once by the debtor DFSP. And the rule for the switch then is only perform the liquidity check if the debtor DFSP is directly attached to your scheme. Obviously, a proxy's good funds must be sufficient to settle in either scheme, but there will never be a problem once both schemes have settled. And in that case, position accounts for the intermediate proxies are allowed to exceed settled funds. And finally, reporting. Well, we're saying that any participant should be able to see the full history of any transfer they were directly involved in. For FXPs, obviously, this means the currency conversion only. And any scheme should be able to see the full history of any transfer that passed through their scheme. Every scheme and every participant will see the same message since we're not doing content conversion. And linked schemes will need to have a merged reporting database with proper segmentation, which will allow administrators to see only the parts they should have access to. And that's all I have on that.
Thank you, Michael. Thank you, Michael. I think we also did the discovery piece on that as well, so thank you. Unless
Yes.
you want to address that separately.
Well, I do have a more up-to-date thing which goes into more detail.
Well, can we quickly go through that, please? I want to give the workstream leads time to start taking the lead on that.
Sure. Hold on a moment. Let me share my screen again. Oh, here we are. Okay, you seeing that?
Yep.
Okay, so this has got more detail about how discovery works without being event-driven. So the model that we're looking at here is we've got a regional switch and 4 jurisdictional switches, each of which is connected to the regional switch via a proxy. So that's a hub and spoke arrangement. Okay, so we start off, FDH Bank, get in Malawi, gets a request that says, I want to send 1,000 Malawian kwacha to this phone number. First thing it says is this an on-us transfer? If it is, we process the payment locally. If not, we send it to the switch. And this is all standard stuff now. And we ask the switch, who owns this one? The switch asks the phone number oracle via the ALS, of course. And the oracle says, I look in my data store and ask whether I know about it. If it's yes, then it's a local to the switch, the FSP. You get the result back immediately. If it isn't, then we say, do we already have a query of this type? If we do, then stop. There's no point in doing it again. If we don't, I get a list of my proxies. I set up the data structures to store the information relating to this query, and I forward the message to each proxy, which in this case is just the one which is attached to the regional scheme. So that gets a message that says exactly the same as the message that was originally sent from FDH Bank, who owns that phone number. Now let's see what happens in the regional switch. The message comes in, as we've just seen, it's passed across without conversion, and it arrives at the Malawi proxy in the regional switch. It's sent to the regional switch, which goes through the same process. Do I know about it? If I do, then I send it back there, and the result is sent back through the Malawi proxy. If I don't, which is what we expect the query in this case to be like, we ask exactly the same question. Is this a duplicate query? If it is, then we stop. If it isn't, I get a list of my proxies. I set up the data structures, and I forward the message to each proxy. So now the Zambia proxy and the Uganda proxy and the Kenya proxy all get the same message. Who owns this phone? Ooh, I didn't do that right. Anyway, so here is the Zambia scheme. That's not doing very well, is it? Okay, we'll think about that in a bit. So the Zambia proxy gets a message. It says who owns this phone number. It forwards it to the switch, which forwards it to the oracle, which says, if I don't know about this, is it a duplicate query? Doodly, 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 doodly. No, I get a list of my proxies, forward the messages to the proxies, and if there aren't any, then it's not found. If there are, which is what we expect, it comes back with a message. Oh, sorry. Comes back with a message that says Zanico is the owner of this phone number. So the message is forwarded to Zanico in the normal way, and Zanico just gets a message that says, do you own this phone number, which it's used to getting. It collects the beneficiary information, says, yes, I own it, and sends it back to the proxy via the switch, of course. So at this point, we would expect to have a message that says, yes, I've got this. Now, when it comes back into, oh, sorry, no, we're going to talk about the Uganda scheme now, which doesn't own this message. So it sends the message to the switch sends it to the phone number oracle. The oracle says, do I know about it? If it is found, it processes it in the same way we've just seen. If not, is it a duplicate query? Stop if it is. If not, get a list of my proxies. If there are any proxies, forward the message to the proxies. But in this case, we expect there not to be any. So you get a not found message going back to the regional scheme. Okay. Now let's look at what happens in the regional scheme. We get a response from the national scheme. We find the query to which this is a response, i.e. the corresponding get for which this is a put. We decrement the query counter, which you will recall will have been set to 3 when we originally sent out the request to 3 proxies. If the response is if the response is negative, we ask, is the counter not? Then we just stop. So we decrement the counter. We haven't got an answer. We just keep waiting. If it is 0, then that means we haven't found it anywhere. So we return the not found message to the caller. It goes back to the Malawi proxy and we'll go back to Malawi switch. If it's positive, we store the association in the oracle so we can use it later. And we return a success message to the caller. So again, the result goes back through the Malawi proxy. And that's how that works. So you'll notice that it doesn't currently, or it doesn't now need to do event-driven processing. All of the oracles are set up in exactly the same way they're set up now, but we don't need to distribute them across the various schemes which are connected together. So we don't need to have a single directory which includes all of the identifiers relating to the schemes. So that is how I think that sort of thing ought to work.
Okay, thank you, Michael.
Oh, actually, can I say one more thing?
Yes, please go ahead.
So one of the things that will happen up at the top right here is the regional scheme will get a response back from the national scheme of Zambia. That response will say, this comes from Zanico and it's going to FHB Bank. At this point, the switch will say, okay, now I understand that if I need to reach Zanico, I need to go through the Zambian proxy in order to do it. So it stores that association. It's building up a table of the associations, the proximate associations between proxies and the DFSPs which they represent. And it will do that with every message it receives. So either the sending institution or the receiving institution will always be associated with a proxy when the switch needs to process it. Okay, that's all I have.
Right, thanks, Michael. Can I ask where these decks are? We need them to be accessible to the workstream leads.
Sure.
And the fact they're workstream contributors.
I'll put them in, well, yeah, I'll put them somewhere in GitHub.
If you put them somewhere in GitHub and then let me know, or on this particular workstream Slack channel, that would be helpful.
Hmm?
There is a workstream Slack channel for this, isn't there?
Yes,
Not
I think
yet,
so.
but they're very soon. Oh yes, there is into Scheme. Yeah. We can use that one, I think. Okay, thank you. I noticed that Kareem has asked a series of questions on the chat. Julie, I can see your hand up, but would you mind if we addressed Kareem's questions first? Michael, can you see the questions?
Yeah, I think the questions are, I'm just reading, well, I will go one by one. So first question, what is a proxy? Does it represent a legal entity, or does it represent the obligations of Scheme 2 towards Scheme 1? So the proxy itself is just a message passer. It's not taking any responsibilities other than receiving messages from one scheme and forwarding them to another scheme. If what you mean, Karim, is being accounts and who controls them, then the answer is that this model leaves that indeterminate. It is for the implementer of the scheme of schemes to decide how they want those ledgers to be represented by actual accounts. There will, I imagine, be scheme rules which are applicable to a proxy on both sides. But one of the things that we wanted to do in this model was to minimize the number of things that a proxy did. I mean, effectively, to bring that as close to zero as we could. Does that answer your question, Karim?
Yes.
Right, where multiple national payment schemes. Yes, that's correct. Actually,
point 2 of the first questions. Yeah.
What do I remove?
Actually, the proxy will represent not only the regional payment scheme, but all of the other national.
Oh, yeah. No, but you told them 1,950. Huh?
Alan.
Oh, yeah.
Alan, you are
Alan.
Quanto già dice? London francs.
Okay, sorry
Okay.
if I've muted
All
Alan.
right, so
So carry on.
So your second set question on the timeout situation. We don't agree with that. We don't. We think that the safe place to have the, I mean, don't forget, a hub and spoke topology is only one of the topologies that we want to support. We might support a topography which doesn't have a regional payment scheme, where there's simply a series of interconnections between different schemes. In that case, there would be no way of deciding which payment scheme should be, as it were, the single source of truth. But it's not the case that the regional payment system will be the one doing the settlement of funds. A situation that we definitely want to support is one where jurisdictional schemes and regional schemes could settle independently of each other. And the plan here is not that the regional scheme will do all of the settlements, but that the jurisdictional schemes, each of the jurisdictional schemes, will be able to settle on a timetable that is appropriate to it. And the regional scheme, or any of the other schemes, will also be able to settle on whatever timetable suits them. Given that that's the case, hold on a moment, Karim, I will get to you. I can see your hand is up. Given that that's the case, we think that the best place for the timeout, single source of truth, is as close as possible to the creditor DFSP. The reason we think this is that the creditor DFSP switch will be the last point at which the payment arrives before it's processed by the creditor DFSP, and therefore it will be the first to pick up a timeout. So that's why we decided that we wanted to do it like that. Now, Karim, sorry, you have your hand up.
Yeah. So see, there are two models which we are discussing. One is hub and spoke model, and the reason why I mentioned the hub should be the one giving the final source of truth is because from a legal standpoint also the hub will be doing the settlement between the national payment schemes, and it will be responsible to commit a finality of payment. So effectively, like if we see almost all of the instant payment systems implemented, and I can give a list of at least 6 or 7 deployments which I've seen. The standard method is that the participants of a DFS of a scheme rely on that payment scheme to give the finality of the settlement. So in a hub and spoke model, the hub for the national payments schemes actually through their proxies are being representative as the participants in that regional scheme. And for that regional payment scheme, it will be operationally feasible because, for example, if we say that the creditor DFSP, which is in this case, let's say in a hub and spoke model, is the national scheme which is receiving the funds. If that decides on finality of a payment, and as soon as it processes an incoming transfer, it allows it settles in its central ledger that payment. If it posts that, then we will have an anomaly that the central scheme would not have posted that transaction in its central ledger and would be waiting for. The transaction status would not be final from that regional payment scheme. So I understand like Moja Loop supports the model where once a crediting party responds to a transfer request, and the configuration is such that the hub, which is Moja Loop in that case, can post the transaction only after receiving a transfer confirmation back from the DFSP. So essentially, and this is how ISO 222 based a lot of payment schemes work. So in a hub and spoke model, we will probably need to consider this because the settlement between national payment schemes will be governed by the hub. In a bilateral model, as it is suggested that the creditor, the scheme to which the creditor DFSP is linked, they should be the ones to decide. Now, what if a situation that the scheme which is at the receiving end, they post the transaction in their ledger and the creditor DFSP credits the account. But if its response does not reach the sending scheme and it cancels the transaction in that case. So we will have a situation where the funds are released on the debiting side and not and credited also on the receiving side. So I would refer to one leg out scheme, which is recently the work done by European Payment Council, in which they connected, they given a framework for SEPA-based entities connected to the European payment system with other non-European payment schemes. And it's always safer to hold the funds till the confirmation is not received from the entity which is going to determine the finality of that payment. So sending side actually will have more control.
Karim, can I give Michael an opportunity to respond, please, to this before going on?
Yeah,
I'm
sure.
just conscious we're running out of time here. Michael, do you want to respond?
Yeah, as I say, one of the one of the fundamental principles that we proposed to ourselves when we were thinking about this is that we should be able to support different topographies independently of each other. I do not think that in a hub and spoke situation, the hub will necessarily be settling on behalf of the spokes. It will settle the obligations relating to its participants, who may be DFSPs, maybe FXPs, maybe proxies. But our idea was that the safest way of doing this was to allow each scheme to settle on its own terms and to have an architecture which allowed that to be the case. Now, I think talking about something like the one leg out proposal is something which works in Europe. And it works in Europe because basically the European payment system says we'll throw something over the fence, and if I decide I don't like it, I will cancel it. This is not the way in which modular loop systems work. And I think that it never, well, I hope that it never will be the way in which modular loop systems work. I mean, in a modular loop world, once a debtor DFSP sends a request for a transfer, it resigns any rights over the outcome of that transfer. It resigns them to the switch and to the creditor DFSP. But it can't, in our world, do anything to that transfer. And therefore, the one leg out model does not work correctly in our world because the debtor DFSP can only know about the finalization of a transfer when it receives a message verifiably from the creditor DFSP, no matter how far across the network that may be.
Okay, thank you, Michael. Julie, you've had your hand up for a long time. Please go ahead.
Yeah, so I think like a few questions from my side, right? And I'm happy to get an answer offline as well. Number one, like I know we had a lot of discussion at the convening around all of this topic, Michael, right? Around timeout and so on. So is the latest design taking this into account?
Yes, I think so.
Okay. And
The discovery work, yes.
Yeah, it was around the discovery
Yeah.
indeed, and around the timeout as well, because I remember we drilled down to some scenario and Sam also provided extra information. So I think when it comes to timeout and so on, like we should really look at all the possible scenario. And then I think for me, like another thing is in terms of the what, so perhaps I finish with all my solution point and then let's talk about organization. Like how do we get the chance to discuss and brainstorm of the stuff that are like, you know, even discussed by Karim today? I think for me, like, I'm not sure we should talk about cancellation. I think we should talk about reject. When it comes to SLA, like actually on the one leg out, you will see that the SLA are very different if it's a SEPA payment. And I read the document that, like, you know, you're kindly share within the chat as well. And I think for me, like when we talk about finality, I'd like us to make sure that we all understand the same thing, because from my experience, finality have a different meaning based on who you're talking to and where you are in the world. So I think, like, you know, perhaps it would be worth it when we have this type of discussion, like, you know, to make sure we all agree that the term means the same thing for everybody, right? And my last point, perhaps, and then I stop, is so we have this work stream, which is multi-scheme, and there is also, like, you know, the proxies for TCAB and PAPS. I feel these two work streams are not mutually exclusive. As we discussed, right, a bit earlier on, okay, like we need to think of how do we decide whether we route the message within module loop or it goes to TCAB and PAPS. And that's exactly the solution you presented, right? So how do we make sure that, like, you know, we are not doing the same work on two work streams, if that makes sense.
Yep, completely agree, Julie. Absolutely. It's not something that we can decide right now, though. We are in the last, what, 13 minutes of this session. So
Can
I
I
said,
just go back and pick up Alain's
yeah,
point?
please do, please do.
Alain has said that the question of timeout should not be put on the creditor DFSP, and I agree with that. The plan is to put it on the switch to which the creditor DFSP is attached.
Yes, I think that's an important
Directly
distinction.
attached, that is.
Yeah. Yep. Was that
Sorry,
Alain?
Alain, does that
Yeah.
answer your question? Not sure.
Alain, are you hearing?
Maybe not.
Yes, so, yeah, sorry about that. Yeah. Sorry about that. Yeah, so still, I think, in my opinion, we would still have the same issue, because there are going to be instances where the DFSP, I mean, the switch where this DFSP resides would still send us their response, or at least they think they have sent us their response, but the response never gets to us, right? To the original switch, if I can call it that, right? In that situation, we'll never know whether this was a timeout, and they'll never know either that this was a timeout, right? So we'll basically still have some transactions that are going to live in limbo.
So that will be the case. Well, sorry. My understanding, and perhaps Sam or James could correct me if I misspeak on this. My understanding is that when a message is sent out by the switch, it will wait to receive a response, that is to say, an ordinary HTTP response. And if it doesn't within a given time, it will retry. So it is only in the case, I think, where the connection is never restored that this will be the case. So what we're doing is we are relying on the underlying resend mechanism of the switch, which it currently has, to ensure that eventually that message will get through. Now, you're absolutely right. If we wind up connecting switches to each other in, I don't want to say flaky, but let's say suboptimal ways, then we might wind up with problems in the communication between switches. But our feeling is that it's much less likely that you'll wind up with communication mismatches between switches than that you will wind up with communication mismatches between a switch and its DFSP, or a DFSP and its switch. Because we would expect that the switches will have higher quality communications than may be the case for instance, small MFIs or SACCOs, those kinds of institutions.
Okay, so yeah. So if for some reason the receiver will have to wait for an acknowledgement from the original switch, then yeah, this would basically work. But in the event they don't, that was what I was looking at.
Yeah.
Right. Okay.
Well, as I say, we're relying on the underlying resilience of loop switches to take care of that.
Got it. Thank you.
And I'm very happy to say that I don't seem to have been corrected by my technical gurus, which
Well, I was just going to say, yeah, all
warms the cockles in my heart box. So I should have kept quiet.
All assumptions being true, Michael, that you mentioned, then yes, I would just say that I think the fallback position is that the API specification and hence the likely scheme technical operating guidelines would mean that the DFSPs would be retrying as well. You know, if communication fails at any point along that chain, the entity who is expecting a response but doesn't get one can retry, and they should. That's why the API has those query methods to allow you to query the status.
No, absolutely.
Yeah. So, Although the specification doesn't enforce it, you would hope that technical operating guidelines of the scheme would encourage DFSPs to be retrying those requests before they process their timeouts.
Yeah, they cannot unilaterally time out in any case. They'll need to take advantage of the query. And I think even the way the API designed with the asynchronous nature addresses some of this along with the idempotency. So as long as the proxies and the tools such as PIM Manager, which sit with the DFSP boundaries, are able to handle, this should be taken care of, as Michael suggested.
Okay, thanks, Sam. Kareem, you wanted to come back in?
Yeah, I can see that we have two different point of views. One where we are saying that, sender switch takes the responsibility to post the transaction in its central ledger, and only then receiving switch posts the transaction. The other option is that receiving switch posts the transaction as soon as it receives the confirmation from its DFSP. Even if its response does not reach the sender switch, then in that case, obviously the sender payment scheme sender switch will need to not release the funds until it knows that whether the transaction was posted or not posted in receiver switch. So, I mean, one way to think about this is that, if we are saying that Moja loop can be adapted on both the models flexibly, then our system design should be such that it allows the configuration of a switch in both manners. But since we are thinking about implementing Moja loop in a real world scenario where there are payment systems which are already there, so we will have to actually look at how the existing ISO 222 based payment systems, at least in the target countries that we are looking at, I'm not talking about Europe, but in Africa, are operating and how they treat the finality of payment. So assume like most of the payment systems manage their central ledger based on a confirmation by their crediting party or the DFSP who is on the receiving end. But when they are participating in a bilateral or in a regional payment system, then that could change because their role is not to finalize the transaction always. They will need to work according to the payment scheme rules. So one of the examples which we have recently worked with is designing the connectivity of the national payment system in Pakistan, which is RAS, to the Arab world. And in that scenario, the teams agreed that the sending switch should take that finality decision, whoever is initiating that transaction. So from a product design perspective, if we keep both options open, that would help in adoption. That's my take.
Okay, thanks, Kareem. We are running out of time here. I'd like to give you a chance to respond, Michael, but I really don't think we have time. We have lost one of our workstream leads. Innocent had to leave. I can see that you're still on the call, or you were a few seconds ago when I checked. I would suggest that that you convene a follow-up meeting here to more tightly define the work to be done during this PI. It's not really the job of product council to define your workstream objectives from this point on. You mentioned a separate message that you're taking some time out because you're doing some academic research. So who is going to be standing in for you in the meantime?
From this Awakdin,
Yes.
comment.
Well, it's
No, go ahead.
It's not. Min, you're going to take over as a work stream lead, are you?
Oh, no, I'm not.
No.
I'm not nearly qualified to do that.
No. Okay.
We were just suggesting that E&I and Kareem were talking that while she's at Yale, Kareem could potentially stand in for a few weeks if Kareem is amenable to that. And of course, this our work have resources to support you, Kareem. Sorry to put you on the spot.
You wouldn't prefer it was somebody from VitsaWorks. So to ease the handover later.
Actually, let us discuss and then we'll revert back to you.
Yeah,
Is that okay?
okay. I'm just a little concerned because this is a critical work stream for us. And we have one work stream, Innocent, work stream leader Innocent, who has had to leave early today, and we need somebody else to take it on. To be honest, I'd prefer it to be someone from VitsaWorks, but okay, let's take it offline then.
Yep,
And
we'll get
we'll
back to you
discuss it
soon.
then. And we need to convene a follow-up meeting as soon as possible to tightly define the work stream objectives, if that's okay. So Min, I'll be in touch with you after this, and we'll get something set up as quickly as possible, if we can. And
Fantastic.
Kareem, it's no offense to you, it's just I know you've got a ton on already. You're already leading merchant payments and you're actively participating in other work streams. I don't want to overload you. I want to give you the opportunity to contribute where you feel you're doing best at the moment. So okay, fine, thanks. Well, we'll leave it there. Min, I'll be in touch shortly, and everybody else, I'll get back to you on the joint work stream lead alongside Innocent, and hopefully we'll get this defined ASAP. So thanks everyone for your contributions today, and speak to you very soon, I think. Thank you, everyone. Goodbye.
Thank you all.
Thanks.
Thank you.
Thank you. Bye.
Thank you.